All right, this is the Unit 13 review. For this first section here, it's just defining these different variables. I've gone through and I filled it out here in blue, and you can go ahead and just read those over. I think that they make pretty clear sense, but just make sure that you understand what all of these means. This over here, under pressure, it says force per unit area, and it says pounds per square inch or newtons per meter squared, that should say. So that's what's going on there. So as I said, you can just read through that and make sure that those make sense. Down here on the bottom, this is finding gas laws, and this is actually a pretty important section. So I'm going to remind you how you do this. You always start with PV equals nRT. And the way that I think about it is if you want to bring one of these variables to the other side, you're going to put it in the denominator on the other side. So for instance, if we wanted t on the other side, we'd get rid of it and we'd bring it down into the denominator here. All right. If we wanted v on the other side from PV equals nRT, we would put it in the denominator on this side and get rid of it on this side. Okay, and that's just doing a simple division on both sides, and I think thinking about it that way will kind of help in terms of figuring out how I get these things rearranged. So yeah, all of these we start out looking PV equals nRT. For the first one, we're relating P and V, so we want to get them on the same side of the equation. Well, they already are on the same side, and everything else is already on the other side. So the idea is here that these things are all constant. And so then we get P1 V1 equals P2 V2. For the second one, we're relating V and N. So we start off with PV equals nRT. What I'm going to do here is I'm going to pull the n over to the left side of the equation, and I'm going to get the p over to the right side of the equation. So it rearranges to v over n equals rt over p. And the idea here is that all of these things would be constant. Okay, and so we get v1 over n1 equals v2 over n2. For n and t, those two are already on the same side of the equation, but we got to get rid of the r there. So we just bring the r down, and we get pv over r equals nt. These ones are all constant. All right, and so we end up with n1 t1 equals n2 t2. And this last one says that it wants you to relate Pn and T. So if we're looking here at PV equals nRT, in this case, N and T are already on the right side together. So I'm going to try and bring the P over there, and I'm going to bring the R over to the left-hand side. And so we end up with V over R equals NT over P, which gives us N1 T1 over P1 equals N2 T2 over P2. Now I'll say with any of these ones that have fractions in them, you could have the exact reciprocals. So this one you could have ended up with P1 over N1 T1 equals P2 over N2 T2, and it'd be exactly the same. Okay, that just means that you went the other way when you were rearranging your variables. So if two things are equal, the reciprocals are also equal, and so if you got these fractions sort of upside down, that's actually exactly the same thing, so it's fine. All right, here are the 8 properties that I've described at the beginning of the unit. If you want more information on those, you can go look at that gassing up PowerPoint. I've put that online along with the video and just the PowerPoint itself. So look through those, try and see if you have any questions on that, and you can come in and ask me. But those are the 8 factors or 8 properties of gases. Going through these calculation problems, there are 2 types here. Remember, there's the one where we're plugging into PV equals nRT directly. If we're plugging into PV equals nRT directly, you have that R there, so you have to be really careful about your units. You have to get them exactly right. If you're doing the proportionality laws, the only rule is that you can't have things in Kelvin, so make sure that you don't have things in Kelvin there. All right, this first one here, it gives you some information. We've got volume, it gives us temperature, it gives us number of moles, it asks what the pressure is in PSI. And so for this one, we're going to use PV equals nRT. If we look, we have a bunch of different, these different things here. We've got R, so we got to make sure everything's in the right unit. Pressure is going to be what we're finding here. So P equals V, 35 liters. Okay, then N in this case is 15. R always 0.0821. And that's liter atmospheres per mole Kelvin. And so that's why on this one we're kind of locked into the units. Temperature, 295 Kelvin. Okay, we go through and we calculate there, and we get P equals 10.4. Now what you have to think here is what the units are for that. And since we plugged it into PV equals nRT, it's going to come out in atmospheres. So that's what we get. We then have to convert that. So I'm going to say 10.4 ATM. All right, and so I want to get into PSI. So I'm going to put ATM on the bottom, PSI on top. All right, and then we know that there's 14.7 PSI and 1 ATM. You multiply those together, you get 153 PSI. Question number 2, this is another PV equals nRT equation. So we're just plugging things in. In this case, we're looking for volume. Pressure is 1.2. Volume is what we're trying to find. Number of moles, 10. R is going to be 0.0821. Temperature is going to be 300. And so go through, calculate all of that. You get V equals 205 liters. For number 3 here, this is a gas's initial volume of 450 centimeters cubed. If the gas is heated from 20 degrees Celsius to 50 degrees Celsius, what's the new volume? So this is a proportionality problem. We're relating temperature and volume to one another. The big thing here that we got to focus on is we got to change these temperatures into Kelvin. So 20 degrees Celsius is the same as 293 Kelvin. 50 degrees Celsius is 323 Kelvin. Then we're going to go through, plug these in. We get the proportionality law. It's V1 over T1 equals V2 over T2. V1 is 450. T1, 293. V2 is what we're trying to find. T2 is 323. Go through and calculate that. You get V2 equals 496. And then since the original volume was in centimeters cubed, we're going to get centimeters cubed here for the end. All right, for this last problem, number 4, this one is another comparison one. We're comparing volume and pressure, so we're going to be using a proportionality law. The one between volume and pressure is P1 V1 equals P2 V2. So we plug things in, 250 times 4,500 equals 2,500 times V2. Go through and calculate that. You should get V2 equals 450 liters. All right, that is that. If you have any questions over any of that, make sure that you come in and see me.